We're going to look at real numbers. All the numbers you've dealt with up to this point are referred to as complex. And complex numbers can be made up of three groups. Real, those that don't have any eyes, pure imaginary, those that only have eyes, and then imaginary that have a combination of both. So real numbers are like 5, -7/2, pi, square root of 2. Pure imaginary are those that have eyes in front by those numbers. So like a 5i or a -7.8i. Imaginary have a real part plus a part that has the eye, the imaginary part. So anything that's a real part without eyes, plus something that does have eyes, that's imaginary. Real numbers can be broke up into two subgroups of rational and irrational. Rational are those that can be written as a fraction, but don't necessarily have to be. And then there's irrational, those that cannot be written as a fraction, and that would be referring to anything that goes on forever, never repeats, never terminates. The rational group can be broke up into integers and non-integers, basically those that can be written as nice normal numbers and those that can only be represented as a fraction. And then integers are natural, which are the positive integers, 0, and negative integers. You may come across the word whole numbers, and the whole numbers would be 0 with the natural. So natural are 1, 2, 3, 4, 5, and so on. Whole numbers would be 0, 1, 2, 3, 4, 5, and so on. Pictorially, it would be represented like this. Everything in the big purple would be a complex number. Inside that would be real numbers, which are divided into two groups, the irrational and the rational. And then over here, a subgroup of the rational would be integers, and then a subgroup of the integers would be natural numbers. So classify each one of these. Well, this first one would be referred to as a natural. This would then be a negative integer, but we're going to just classify it as an integer. This would be a rational because it's a decimal that doesn't go on forever. This is also rational because it is a fraction. This would be a pure imaginary because it has an I. The next one down we would say is complex. You could also just say it's imaginary because it has a part without eyes and a part that does have eyes. This is a square root, and it does not work out to be nice, so it's irrational. This is also a square root, but square root of 49 actually works out nice to 7, so that's a natural number. And 5 to the 1/3 is really the cube root of 5. That's not a nice, neat number, so that's referred to as an irrational. Now, to review here, we have a negative exponent. A negative exponent moves it to the other part of the fraction, means reciprocal. So here, the reciprocal of 5 would be 1/5. So here we have to do the reciprocal of 1/2. So it's going to put that 1/2 in the bottom of a fraction. So it's going to be 1 on top, move that 1/2 down to the bottom. And then 1 divided by a fraction, instead of dividing by a fraction, you multiply by the reciprocal, we get 2. That's one way to think about it. You could have just thought, well, that negative exponent is going to flip the fraction upside down. You flip the fraction upside down, you get 2. So how do we add fractions? Well, to add fractions, you have to have a common denominator. How do you multiply fractions? Well, to multiply fractions, you have to just multiply the top and multiply the bottoms. The tops are referred to as numerators. The bottoms are referred to as denominators. Well, what do you do for dividing fractions? Well, you multiply by the reciprocal, and it's always the reciprocal of the second fraction. So down here, we want to know, is this expression going to be positive or negative? So we know that x is less than 0, which means x is negative. So if x is on top here, we know we'd have a negative here. X is on the bottom here, we know we'd have a negative there. We also know that y is greater than 0, so that means y is positive. We have a y in the bottom here, so we know that that's positive. We have a y in the top here, we know that that's positive. So here, you have a negative divided by a positive, which you should know as being negative. Here you have a positive divided by a negative, so you should know that that's also going to be a negative. And now you're negative and you're adding more negatives, so that means your overall final answer would also be negative. Absolute value. Remember, absolute value is distance from the origin on a number line. Well, absolute value of 5 means we're just 5 units away on the right. Negative 4, absolute value of negative 4, well, that's just 4 units to the left. Now, if the number is positive inside, your absolute value really didn't do anything. If it's negative on the inside, your absolute value actually did something. So what are we doing to that inside to be able to get this? Well, we're really doing the opposite of that. The opposite of a negative is our positive. So once again, if it's positive on the inside, your absolute value does nothing and just leaves you with what you did have on the inside. If it's negative on the inside, your absolute value makes it positive by doing the opposite of what was on the inside. Now, in mathematical speak, it's given to you like this. If you're positive, then your absolute value does nothing. If what's on the inside is negative, then you do the opposite of that. So it could be written like this. This would be referred to as a piecewise function, but we'll be getting to that later. Now, whenever you come across this expression here, all it means is you're just looking at the distance between 2 points on a number line. To find distance, we know distance is positive, and to figure out how far apart they are, you just subtract the two numerical values that correspond to the points. Like if you wanted to know the distance between 17 and 11, you go 17 minus 11, or you could go 11 minus 17, but in absolute value and make them positive. So that's all we're saying. So here we're looking for the distance between x and 8. So we have to subtract those. But to ensure that it's positive, we're going to put it in absolute value. Then we want it to be greater than 1. So I'm going to go greater than 1. Now, what we have here is perfectly fine. Because of the absolute value, the x and the 8 could be flipped around. Oops, sorry about that. And you could write this instead. Either one of these would be totally acceptable for this problem. So, got a question for you here. We have the absolute value of 3 minus e. And then we have the absolute value of e minus 3. Well, we need to think e is the natural number e, which is about 2.7, blah, 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 that you learned about in Algebra 2 or Accelerated Algebra 2. So 3 minus something about 2.7 would be positive. So the inside's positive, and you got to think, well, if the inside's positive, absolute value doesn't do anything, and so we would just write 3 minus e. But if you have this here of about 2.7 minus 3, you'd be subtracting something bigger. 2.7 minus 3 would be negative. Since the inside's negative, your absolute value is going to make it positive by doing the opposite of that. So this right here goes to the opposite of what was on the inside. Then you could go ahead and distribute that through, and you could either write negative e plus 3 or 3 minus e. It would not make a difference. And then we're going to wrap up with scientific notation. With scientific notation, you want to go ahead and move your decimal point. And by the way, your decimal point right here now is here. You want to move it so that there's only one digit in front. So in this case, we had to move it once, twice. So we're going to go 5.13 times 10, and the exponent on the 10 is how many decimal points you moved it. So here, our decimal point was here. We're going to want to move it to here. Then you got to count how many places did I move it. 1, 2, 3, 4, 5, 6, 7, 8. And you're like, wow, Faulkner, you can actually count. Oh, yeah, that happens. So, whoops, here we go. And our exponent's 8 because we moved it 8 spots. And the same idea here. We got to move our decimal point to where there's one digit in front of it, and then you got to count how many times you moved it here. and then you write it. But because we started out with a really tiny number, our exponent's negative. And so here on this one, we got to take our decimal point and move it 8 places to the left. Well, if we move it to the 8 places to the left, that would put 7 zeros in there, and we would get this.